Right, that's it. Done all my deliveries, bar one. I've got one left to do. Let me just check the map. I had 8 to do today. 1, 2, 3, 4, 6. So I'm going there. All right, I'm going to arrival. Okay, check my mirrors. Digital mirrors, of course. More efficient. Very, very nice. At least the van is comfortable to drive in. I mean, I've been doing deliveries for years, and the old vans, the rattling diesels, terrible. Drive you mad, and the gears and the clutch, it's all rubbish. But at least with this one. So now I'm looking for arrival headquarters. I'm on a big industrial estate in Banbury in Oxfordshire. Let me see if I can find. That looks hopeful. Yep. Okay. Deliveries. There's a big sign. Tells me where to go. Perfect. There we go. Brilliant turning circle. Look at that. Fantastic. That is perfect. Right. Let's just check my logistics. What's the number of the parcel? Yep. Okay. That's all good. That's my last package. Look at that. Brilliant. Done all those deliveries. Now, it might surprise you to discover that I'm not actually a delivery driver. No, that was just my brilliant acting. But what we've come to see today is the next developments that Arrival are doing here at their incredible R&D facility. It's just amazing what's going on here. This is the new Arrival delivery van. That is Arrival's R&D centre, and this is fully charged.
Don't forget our great EV giveaway. Subscribe and enter for the chance to win one of several electrifying prizes, including one of 4 electric cars.
So Mike, I've seen the bus before when we came last year, but it was over there and it was basically a box with a lot of wires hanging out. It was not bus-like. This is really, I know it's not, this is still a prototype, isn't it? But this is looking really, really good. Really
look,
impressive.
I think that's the first thing to clarify. It's still a prototype, and the purpose of this vehicle is testing what we've designed, right? Now it's even a fairly early prototype in all transparency. We have later prototypes.
Right.
So don't assess this by build quality and such, but it is very representative of the physical bus as it'll come to market.
Right.
So I had to say it is beautiful, I think. I think they did a fantastic job on it. So,
I mean, it just does look, it looks suitably different to, because I mean, you could effectively have this on the front of a bus with a diesel engine at the back. In that sense, but I can tell that the flat floor that goes all the way through to the back is just, it's such a relief. There isn't a massive hump at the back with this hot, noisy engine in it.
Yeah, absolutely. So within the bus, you'll notice, so the flat floor is one of the key things, right? Yeah. And you'll talk to Scott in a little while. He'll take you through some of the challenges on that. A flat floor has a lot of advantages, primarily for the rider.
Yeah.
But also you can think of just cleaning and such. It just comes very easy.
Yeah.
And if you think of what we're driving for with the bus here, is there's kind of 3 different personas in a way. So one, it really does all start with this notion of radical impact, right? And it's an expression, but it really has to stay as a driving principle of it. So the bus needs to be compelling enough to get people on it, and that's one of the big things. And what we'll talk about in a little bit is it's not just the physical bus then, and the technology that goes on it, but the infrastructure around that, the services that to start coordinating and such. But the bus itself, the flat floor, belies the technical challenges of we have a mandated height of the floor and a mandated height off the ground.
Right.
So there's some extreme challenges to bringing batteries at the floor level. What you'll find in a lot of the buses that are on the market today is they're actually in the roof. Right. Because they never designed from the start to put them in the bottom. They're retrofitting existing buses.
Wow, is that the case? So there was already a diesel bus, they take the engine out,
absolutely,
gearbox, and then they put batteries. Because there's something about the stability of a vehicle with very heavy things on the roof that worries me. But
it's a bit counterintuitive, yeah, it worries me a bit too. So, obviously, it gives you the modularity then at this point. Right. So, if we talk about so first the rider's experience was a driving principle, and that's one of the things that gets you into the bus.
Yeah.
So unfortunately, I don't think we're going inside the bus, but there's a long skylight as an example.
Right.
Very simple change, but when you're in the bus, big windows on the sides, skylight above you, makes the experience a lot better. I used to commute on the bus in Sydney, and it was a shaky experience. The windows were fogged up, and usually somebody's on top of you. You really want to make the experience better so that you choose to take the bus.
Right.
So that was a big part of it. But little things like the technology, having USB charging ports and such, that starts to become really important. And you may have seen a corporate video we had was on the usability team, the UX around this, the user experience, and really trying to stay focused on that and refining that. And there's just continuous work on that. So, particularly focused around the driver. I think the driver is a persona. We talk about the rider a lot, and I think that's really the key audience.
Yeah.
But the driver is the one that spends all day in the bus.
And it's a big responsibility. If you've got 50 people in a bus, you're looking after them.
Absolutely. Yeah.
Absolutely. Yeah.
We took this bus out for some driver user experience testing a couple months back. And when you talk to the driver about their experience, it's quite a stressful job actually, because you have to worry about the passengers coming on, paying fares and such. But of course, you have to worry about what's around you at all times. And they were noting to me, they said, look, every 8 seconds, I'm required to check the mirrors. So when you watch them drive, they're constantly checking interior, exterior mirrors, etc. So focusing on them was a big part of what we're trying to do. A lot of it is simplifying their experience. So bringing down the number of buttons and making a user experience that's focused on the task at hand and bringing only the information that they need at the time, which is the exact opposite of my experience on my phone, by the way, which I get notified on everything.
So this is, as Mike alluded to it earlier, this is not the finished article.
Right.
This is very much, we refer to it as the lab bus.
Right.
And this allows us to develop our technology ahead of the final architecture being ready.
Right.
So some of the details on this vehicle, the industrial design, so some of the curves you see on the exterior are not the finished final design.
Right.
Some of the architecture has fundamentally changed from this platform to our final platform.
Right.
But actually this allows us to showcase some of the architecture that we strive for in the products that we deliver.
Right.
So although she's a bit of an old girl and actually she looks a bit rough around the edges, she's designed by Arrival from scratch, ground up, nothing carried over, no donor vehicle of any sort. This is Arrival bus ground up, and it really is a stepping stone of us getting to our Gamma build, which is underway over there behind you, towards SOP.
Right. You've got to explain what SOP is.
Start production. Apologies.
Production. Proper buses coming off
the
of
proper stuff. Yeah.
Right.
None of this development vehicles. The proper saleable stuff.
But then, I love the way that it's designed so that you can make it, you know, depending on what the customer wants, you can make a longer bus or a shorter bus or a bigger or smaller bus.
Yeah. So one of the real drivers for us was to make sure that we could develop a platform that was scalable for the customers out there. Not everybody wants the same bus.
Yeah.
Different cities want different sizes, shapes, specs, and one of the initial targets from our specification was to design a platform that was scalable, that was modular. And modular is a key phrase that's used in our business a lot. And you'll see what we've got here is a 10.5 meter bus, which is your conventional city bus.
Right.
Hop on, hop off. Actually, your intercity would generally be a 12 meter. The difference between the two is it's missing a single module between the wheels.
Right.
That's pretty much it.
So that is incredible. So you would actually put another section, you can see the different sections, another one in there.
Yep.
So the wheels would come back, there would be a longer wheelbase.
Absolutely.
Wow.
And we developed the product to be designed and tested and validated to be the maximum length, let's say the worst case.
Right.
So that we can offer, later on after production, we can offer a huge variation in specification. And what it really truly means is that we don't need to go back to the drawing board.
Right.
And back to redevelop the product because somebody wants a slightly longer one, a slightly shorter one. We've got it out of the box.
Yeah, but presumably you know from, I'm sure, all the data and research you've done into what buses really do, because it's always that thing where the assumption is, oh, your average bus, it's working all day, it does about 1,000 miles. It's nowhere near that, is it? But I mean, it's that you built this with the capacity to do the job that is needed.
Absolutely, and you're absolutely right. A bus on the on the roads today, everybody just sees a bus and just assumes it's a bus, but actually an intercity bus versus a town-to-town bus does such a different drive cycle. One gets to 50 miles an hour on a dual carriageway. The other one in London rarely gets above 10 miles an hour.
10, 12 at the
So the use cycle of the buses is so different depending on where it's being purchased and what it's being used for. And we've developed the product to be as flexible as it can be to cater for all of those different customers.
So, I mean, could one of these be, you could build what we think of as an intercity bus, something that does a couple of 100 miles? Or
Absolutely, absolutely.
Wow, right.
And you know, there's lots of technology to extend that range and to cater for those different customers.
Right.
The key being here is that we're trying to think about that at the front end of the development rather than trying to shoehorn that technology into it post-development.
Right.
That's what means customers need to wait another 3 or 5 years.
Yeah.
So we're trying to do all that now,
Right.
so that out of the box the product's ready for multiple customers.
Right. Napa, I've got to admit to you, I'm a real sucker for robots. I absolutely love them. I love this fella. He's
You're
amazing.
in the right place then.
And then there's all these there. I don't even know what they're doing. This is for the. My basic understanding is the kind of micro factory. The fact that you can. It's a sort of, in a way, a modular or digital factory that you can produce.
What you're actually seeing here are two of the main components of the microfactory, two of the core technologies, the cell and mobile robotics.
Right.
So in a conventional factory, as one you've seen around, you see that everyone is still based around the concept of the conveyor belt, right, on 150. So the product goes through all the stations in a serial manner. This means that you need one factory for one or a couple of vehicles and a few variations to it. So this brings to you a massive capex, to build the infrastructure to build the vehicles. And as you know, we are looking at price parity of our electric vehicles with the combustion engine counterpart. So we realized that we really needed to revolutionize the way we actually build our vehicle to meet our target.
Right.
And this is where this technology comes in. So instead of having the conveyor belt model, we have this series, this set, I would call it, of parallel robotic cells, modulars, which is what you see here now.
Right.
This is one of our R&D ones. Think about it as a little factory inside the factory, right? So you build a full vehicle inside it, or you can build composite panels inside it, you can build components. And you got many of these inside the factories. And these little tanks, these cubes, these smart cubes, are responsible to move everything around in the factory. Be it like a component, it can be 10 bolts that you need to transfer from one cell to another, or it can be a full vehicle.
Right.
And these are smart enough and modular enough that they actually can combine to each other to create larger vehicles, right? So if you have a small part, a battery, you call one robot. If you have a large part, a panel, heavyweight transport to make, these robots combine to each other like Legos.
Wow, so they go along like a train, if you like.
They are shape-shifting, basically. Depending on what you need, these robots can create a new creature, non-biological creature for you, right?
That is so awesome, and I love the fact that they, you think when you first see it, it can only go backwards and forwards, but clearly they can go in any direction.
Yes,
that you require.
they are, how we call them, they are holonomic platforms, so they can move in any direction without steering.
Right.
And the reason why we did this is that the Revamped microfactory, because we want to bring the footprint down. We want to deploy our factories all over the world with as little work as needed. So space is important for us. So we are looking at it in any details. So in order to maneuver with these beauties into narrow spaces with a heavy load, we were thinking, how can we make this happen, right? How can we get both precision and heavyweight transport in narrow spaces?
And then the machines you've got here, I mean, I've seen similar machines in big car factories and everything. So that you've just adapted them to. So will each of the modules that these will take up, will they do a specific task in the build, or could they theoretically put the whole van together, for instance?
Yes, in principle, and as technology progresses, we aim at building a full vehicle inside the cell.
Right.
Of course, we always look for reconfiguration for adaptability, and products can be very different. A van, a bus, so they may have different requirements. So some cells may be specialized for some reasons, right? So you may have cells that are specialized for composites, for instance.
Right.
But the general concept, the ultimate target is to have a full vehicle built inside one of our cells.
Right. So Patrick, I mean, for a start, the thing I noticed today coming back here we were here a year ago, is how much busier it is. Yeah. How many people are working, there's more people working here. There's a lot going on. So in case, there's a lot of noise happening in the background, but it's so amazing to see how you've developed this. So this is the Arrival van that looks pretty different to the one we saw last year.
It does, yeah, and as I say, so actually throughout lockdown we've done a good job of continuing on the critical path that we're working on, building a lot of vans, all out getting a lot of testing underway, super important for us. And this van you see here is different to the one that we saw last time, as you say. So the first vehicle was a direct output of the conversation we had with fleets to make a vehicle which was the most efficient way of carrying cargo possible. So it was a box on wheels, effectively. Highly efficient, but actually we've had such demand from customers around the world, particularly in the US and in other regions, for different products which all have very different requirements, which led us to a design which is more universal ultimately.
Right.
So this design you see here, we've moved the occupant back and upwards.
Right.
Bigger crumple zone, better visibility, better ingress egress, and importantly, the ability for us to scale this to different products now far quicker is the reason we've evolved the product in this way.
So it's not just like the front is slightly different, the whole structure of the vehicle?
Most of it carries across. Most of the changes is in the cabin and the basic load paths, but it's by and large the same product, but we're still managing to maintain the essence of the product, which is the most amount of cargo volume over the footprint of a vehicle compared to any other lightweight van. And that's the important point.
The cab, the driver and the cab takes up a very small amount of the total space. You've obviously got a lot of room in the back.
That's right, and designing the vehicle from the ground up as we have, we've just optimised the vehicle wherever possible. So we brought the windshield as far forward as possible, and it's the first essence of a van which moves away from all of the associations of a combustion engine, ultimately. So very small front end, glass down low, visibility is 20% better than any other vehicle. So a driver's going to see far closer in front of their vehicle than in any other van. And it's those marginal gains we can find across the product from designing it in the way we have ultimately.
And I mean, the other aspect, now that it's becoming closer and closer, that there will be companies that will buy many vans for one depot, is the charging infrastructure at those depots. So are companies now going, hang on a minute, we must make sure we've got the charging infrastructure ready for when we get these vans?
Getting the charger infrastructure ready and then having the conversations with energy suppliers to make sure that those fleets can be ready downstream of that.
Yeah.
But fleets in my experience are very, very clued up on this right now.
Right.
There's very good readiness for this. And of course, as you know, we've got lots of companies and lots of charging solutions that they can choose from. And we're here just to be on that journey with them, help them understand what charging capacity the vehicle has, what's going to be most suited for their fleets and for their duty cycles.
There were so many people that we heard from who just said, I want this as a camper van, which is kind of predictable. Conceivably, by the end of next year, could an individual person buy a van and then convert it to a camper?
Yeah, 2022, 2023, we will be taking consumer sales for these products.
So private, it doesn't have to be, you don't have to be a fleet.
No, absolutely. This is built to be a universal product, and consumers need vans as much as fleets do, as we know. Fleets are the right place to start, but the demand we've seen for a camper van, rightly so, as you say, is incredible.
Yeah.
And so when you get inside the vehicle, you see how simple it is.
Yes.
And
so roomy.
For someone who's converted a camper van myself, you know what it takes to go through that process. And so simplifying the structure, how people can interact with it, is a big advantage, definitely.
So I think what they're doing here at Arrival is genuinely, it's revolutionary. It changes manufacturing, it changes the product. It's not just about the finished thing, it's the way it's made. It's incredible. I'm so pleased that we've been able to follow this, and we'll obviously come back and see some of the other things, because it's possible that they might be making slightly smaller vehicles. I'm just saying, it's possible. So what we've seen today is amazing. I really want to thank the wonderful people at Arrival who facilitated this. It's so wonderful to come and see this. I haven't even mentioned anything to do with subscribing on Patreon. I totally forgot because I was so overwhelmed by amazing electric vehicles. So maybe look at the Patreon link if you want to, and please do subscribe to Fully Charged. That really does make a big difference for us. And that's it, as always. If you have been, thank you for watching.